Number 86 was a slope problem. And it dealt with, I think, the steepness of a mountain. So this is highway engineering. Does anybody know if you go into engineering that deals with like bridges, highways, red lights? Does anybody know what kind of engineering that's called? Roads?
Structural engineering?
Architectural, structural. Some of it might be considered like civical engineering. It just depends, I think, where you go. But yeah, dealing with roadways, red lights. Like red lights are huge on McKnight Road. There's a lot of engineering that goes in with that. You might not think about it, but getting that pattern correct so that one light could follow the other light. So yeah, all of those different types of engineering. But this is talking about a highway, and you're driving down a mountain, and you notice that there's a warning sign indicating that it's a 12% grade. So I don't think we have any. I drive the turnpike a lot because my parents live in Harrisburg, and there are definitely steeper hills on the turnpike, but nothing that has a 12% grade. But if you go down 79 into West Virginia, there is a mountain. Mr. Kane would remember the name of it. It's like blanking me right now. But it's a fairly steep mountain, and you get to the top, and you might be close to a mile above. Like they give you the height of the mountain. So anybody driven in West Virginia before? Mr. Kane isn't around right now, otherwise I'd grab him and ask him because he'd remember what I'm talking about. But the steepness of that mountain going down the other side, it is pretty steep, and it's like big warning signs for truckers saying make sure you pull back your gear. But there's a grade or steepness of the mountain as you're kind of driving down it. So it means the slope of the road is -12/100. So it wants us to approximate the amount of horizontal change in your position if you note from elevation markers that you have descended 2,000 feet vertically. So I want you to think about this a couple of different ways. So thinking about our mountain, like right here, we'll say that's our mountain, and you're going to drive down the road. Remember, slope is rise over run. Well, if it's negative, you're falling. So we have a -12% or -12/100. So that means for every 12 feet I fall, I move horizontally 100 feet. So this is the amount we're falling, and this is our horizontal change. So I'm going down 12 feet for every 100 feet horizontally. So that means I go down 12 and over 100. But you can't physically do that with a car. But that gives us then the steepness of this line right here. That kind of gives us the slope that you would have at the side of the, like going down the road, going down the mountain. So this one wants us to approximate the horizontal change, or X. If your position is 2,000 feet vertically, so you've descended 2,000 feet vertically. So how could you try and create an equation? Because remember, we're talking about equations. How could you try and create an equation that represents this information that we're given?
I said y is equal to -12/100x. And then I set y as -2,000.
Okay, so he's setting y as -2,000, and he has the slope as -12/100. And that sounds good, Peter. I'm just going to kind of take what you had and just extend it a little bit. So thinking about y equals mx plus b. So we have our slope is what they give us. And then if we're descending 2,000 feet, that means I have to start 2,000 feet above the ground. And we're descending the whole way down the mountain until we get back to the flat part. So that 2,000 feet can also be thought of as my y-intercept. So that's where I started. And that's what the y-intercept represents. Well, if I go down the entire mountain, if I started at 2,000 feet and I go all the way down until I get to the bottom, my end height at the bottom would be a 0. So Peter, I'm just like thinking about this slightly differently. You have the same exact numbers that eventually we'll have when we solve this.
Yeah.
So y equals mx plus b, the slope is the grade, the negative 12 over 100. The y-intercept would be my initial point. I started 2,000 feet above the ground. That's the vertical. And I'm going all the way down to the bottom. So I used a 0 to represent the height when I end my decline. And then if you solve this, we would take the 2,000 to the other side because I've descended 2,000 feet. So I should be going down 2,000 feet. And then you solve for x. And I would cross multiply, or you could multiply by the reciprocal, however you want to think about that. So if I multiply by the reciprocal, Peter, what did you get for x?
I got 16,666.67 feet.
Did anybody think about it differently? Approach the problem maybe a little differently?
Did it how Peter did it, but
you did it how Peter did it? Okay, good check. So again, if you set it up like thinking the y means your vertical change, you know the slope, the x is your horizontal change. That's another way of thinking about it. So I was thinking y equals mx plus b because that's what we were talking about. But you can still think that the y and the x variables, y represents a vertical change or a vertical amount, the x represents that horizontal amount. Make sure you're making that number negative though, because you're descending. So the fact that y is 2,000 needs to be negative to show you're moving down. So you're finding x. So anytime it says horizontal change, horizontal value, you're finding the x variable. Any questions on that? Were there any other questions that anybody had about slope, y-intercept? All right, so you are going to get from me a little invitation to join a breakout room. But before we do that, I just want to take you to Google Classroom. So if you want to go to Google Classroom as well, in your Google Classroom today for Monday, there is a link, and that link is the group activity. So a little bit of information. There are 2 word problems. I would like the names of the group members that you're with. So you can place that at the top. Place their names. If you're with 2 or 3 people, put all the names there. And then there are 2 different problems. So one is dealing with college enrollment. And then the other problem I said is dealing with Buffalo Wild Wings. And you're given data for each one of those sets. So 2 problems with a couple of different pieces of information, and they're similar to each other in like the types of questions that you're asked about the data. You will each upload your own worksheet or your own activity. But again, I do want the names of the group members that you worked with. Questions. You can do this just on a piece of paper and then scan it and post it to Google Classroom, or you can do it on in Notability or in Adobe, whatever app you prefer to use. All right, so you're going to get a little notification from me to join a breakout room. So I just need to make sure you hit the join.
pretty simple. So for the slope, it's just 7,000 minus 5,500 divided by
Over
10.
10. Yeah.
So you guys can kind of talk about the problem. I will be back. I'm going to try and pop into everybody's breakout room, but if you have a question, send me a chat so that I can come over and come back to your breakout room.
Okay. Thank you.
Thank you.
You guys can talk about the problem.
I got 250 over.
Okay, so for number 1, we have in 2005, a college had an enrollment of 5,500 students. By 2015, the enrollment had increased to 7,000. What was the average annual change?
Just popping in. Hi, Jack. I
Hi.
appreciate you reading out the word problem. If you have questions, send me through the chat so that I can come back, but feel free to work together. If you do have a question, ask me. So just send me a little chat and I'll pop back into the room. Okay?
Okay.
Thanks.
Okay, so for this,
Well,
So wait a minute.
It'd be 2015 minus 2005 over 7,000 minus 5,500 to find the slope. And then you have to find plus b, or no, I think you just need to find the slope.
And then you plug in one of the points.
Yeah. The 3 of you doing okay? Yep. Yes.
Okay.
If you do have a question, send it to me through the chat and I will pop back into your breakout room. But as you're working through it, I'll give you a couple of minutes to kind of get through some of the problem, but let me know if you have questions. Okay.
All right. It's actually 7,000 minus.
Equals 1,500 x plus 5,500.
I got the same thing for that one.
Okay, cool.
Are you guys good? The 3 of you ladies doing okay?
Yep.
Okay, I know it's a little weird trying to do a group activity remotely. If you run into questions, please send me a little chat like, hey, Mrs. Kane, we're stuck. I'm trying to just rotate through all the breakout rooms to make sure everybody's doing all right. But please send me a chat, one of you, letting me know that you might be stuck on something. You're doing okay so far?
Yeah, I think we're good.
Okay, all right.
I got 7,500.
That's what I
Oh.
did too.
Never mind. Yeah. 7,500. My bad.
Evan and Cole, are you doing okay?
Yeah.
Yes?
My bad, I was muted. Yeah, I'm doing good. I'm on number 3.
Okay. I just wanted to make sure you guys are all right. If you have a question, you'll let me know.
Mrs. Kane, when it says interpret the slope in the context of the problem, does that just mean like, what does the slope mean?
Yes, yes. So what does it mean with this type of problem? So talking about students and years, what does the slope mean for this problem?
Right. Thank you.
Mm-hmm. Are we doing okay in this group?
I have a question about number 3.
Yeah.
When it asks to write the equation of the line that represents the data given in part B, are we writing down the equation that we use to get the answers?
Yes. Yes.
Okay.
So like y equals mx plus b.
Okay. Thank you.
Mm-hmm.
The slope is the annual change in enrollment.
Jack, Kate, and Gianna, are we doing okay?
Yeah.
Yeah.
So what's the difference between what number 3 is asking and what we had to do for number 2? Because for number 2, you had to get the equation of the line to solve it, right?
Correct. Yes. Yeah.
And
So
then number
you're-
3 is just asking what the slope means.
yeah. Mm-hmm. So make sure for
Okay.
number 3 you write the equation, and then yes, what does the slope actually mean?
Okay. That's what I thought, but I just wanted to check since.
Yeah. Yep. So number 2, I mean, like you're trying to use the pattern, but technically, yes, you're using the equation that you probably already made for 2. Yeah. I guess you could flip flop those 2 questions if you wanted to as well.
Okay.
Ladies, are we still doing okay over here?
Yeah, we are.
Okay.
I don't know what the difference would be.
Yeah.
Perfect timing, Miss Kane. We're confused.
Hi. New. It was in my mind. What's that?
So for number 4 on the first one, when it asks us to compare and contrast the slope and the average rate of change, like we just don't know what the difference is.
So there is, I mean, in a sense, they're the same, except the
Okay.
slope you use for just data and the rate of change would be applied to something over time. So like a
Okay.
rate of change deals with talking about time, how does it change over time, where the slope is just like a set of points, 2, 3, 5, 7. They have like no meaning in application problem. That makes sense?
Yeah, because like for number one, it asked us to find the average annual change and we just found the slope. So that's
Correct.
why we were
Yeah.
like, did we do it wrong?
Yeah. So you're not doing
Okay,
it wrong.
perfect.
It is the slope, but it's the slope of application.
Okay. So we just said like they're basically the same, but slope tells just the data points and average rate of change tells like for something over time.
Perfect.
Okay.
Yep, that's great.